Algebra 2, we are going to be going over an introduction to graphing polynomials. So we are going to be referring to page 706 a lot. 706 is the table of all possible end behaviors. I made a copy of it so you could see, and I'm going to tape it in our notes. But end behavior, and we're going to go over that, is based on odd or even degrees, and it's based on whether you have a positive or negative coefficient. So first I want to talk about some vocabulary. Our leading coefficient is the first coefficient if in standard form. It's the first number in front of x, okay? Degree is our highest exponent. So if I have a degree of 1, 3, 5, 7, and so on, right? These are odd numbers, so this is an odd degree. If I have a degree of 2, 4, 6, 8, and so on, these are even numbers. So I would say they have an even degree. So on the left, it references a polynomial that has a leading coefficient of a greater than 0. That means it's a leading coefficient of a positive number. When a is less than 0, that's a negative leading coefficient. And then notice at the top we have our odd degrees, so 1, 3, 5, 7, and our even degrees. Now, end behavior is very specific to the ends of our graph where it's headed in terms of infinity. Infinity is like this sideways 8. And it is another word for forever because these graphs do continue on forever. So end behavior, where the ends of your graph are approaching in terms of infinity. And again, notice I drew the symbol. Sorry, I almost said drew. And I have both positive infinity and negative infinity. So I'm going to do a couple examples with you before we start our lesson practice. So the first, identify the end behavior, degree, and leading coefficient. So I'm going to start with my leading coefficient. In this case is the first coefficient because this is in standard form, 3, 2, 1, 0. So my leading coefficient is 2, and this is a positive 2. And my degree is 3, which is an odd number. So if I use that information and I go to here, I have a positive odd degree. So my graph, this isn't like a perfect, but it's going to have this general shape. And so I'm going to go over how to do end behavior. So let's picture this is our y-axis. And this is our x. It doesn't matter where it occurs. And on the x-axis, this side is positive numbers, but this side is negative numbers. I'm going to go ahead and zoom in. For y, my positive numbers are located at the top, and on the bottom, I have my negative numbers. Right? You already knew that about this. So let's start with the top right. And I'm going to talk about where x is approaching and where f of x is approaching. So please know, and I should have written that up here, that this symbol means approaching. And this symbol is for infinity. Okay? So these are two symbols that we use in mathematics because I want to write the least number of words possible if I'm in math, right? This is not English class. So let's talk about this end here. Now this arrow is going to continue to point up and to the right. So I'm going to look, when I'm talking about x, I'm going to look below my arrow. Okay, x is positive over here. And if it continues on and on and on to the right, is forever approaching a positive infinity. So it's based on where it's located. F of x, which is another way of talking about our y or our output. This arrow is pointing up. And if you look right here, this is positive as well, and it's just going to keep going more and more and more positive. So f of x is also approaching positive infinity. So that is the end behavior for one of the ends of my graph. I then have to do it for this end. Okay, so again, I've got my leading coefficient, I have my degree. Here's the end behavior for one end. Now I'm working with this end. So let's talk about what x is approaching and what f of x is approaching. So x is approaching. Now look where my arrow is. Look right above it. Look at the location. I'm on the negative side of the x-axis, and it's going to continue to point to the negative side. So this is negative infinity. I'm located at the bottom of my y-axis, which is also negative numbers, so f of x is also approaching negative infinity, meaning it's going to continue to approach negative numbers forever. Okay, we're going to do one more together. So x squared minus x to the sixth minus 5x. And I'm going to bring this up on Desmos as well. So first I want you to know this is not in standard form because my variables are not written in order. So I need to rewrite in standard form. So r of x, let's list things in order. This is a negative x to the sixth plus x squared minus 5x. Now I can talk about the degree and my leading coefficient. So for degree, I'm looking at the largest exponent, which in this case is 6, which is an even number. And for my LC, I'm looking at the first number in front of the first term, which in this case is a negative 1. So this is negative. Okay, and then let's now look at our chart. So my leading coefficient is negative, and I have an even degree. So I'm looking at this bottom box here. Now, I know that if x is to the sixth, that means I have up to 5. Oh my goodness, where did they change it? Gosh, I can't think of the term. 5 changes of direction, 1 less than degree. And I know my graph points down. So I would guess my graph could look something like this. 1, 2, 3, 4, 5. Now, I have no idea how tall or how skinny, but I'm going to guess it has a rough shape of that. So I'm going to enter this into Desmos. You do have this availability. And I dimmed this so you could actually see it. I don't know why I didn't think of that earlier. Y equals, we've got a negative x to the sixth plus x squared minus 5x. Okay, and I'm going to, now in this case, notice I don't have a ton of movement, but my graph does point down. So these are inaccurate, but I can have up to 5 change of directions. 5 is the most. In this case, I don't have that many, which means I probably have repeated zeros. So in this case, my graph looks like this. Either way, we can do end behavior. So again, let's pretend we've got our f of x axes and x. F of x is negative at the bottom, positive at the top. X is positive on the right and negative on the left. So we are going to talk about each end. So I'm going to do the behavior for the, and I'll do this in, I'm going to do the end behavior for the left and for the right. So let's first talk about that end right there. Okay. So I have x, and let me go ahead and circle these because it did ask us to identify those. Let's talk about where x is approaching and where f of x is approaching. So if I'm in 1, 2, 3, I'm in quadrant 3, both x and y are negative. So x is approaching negative infinity because it's moving to on the left, and f of x is down below. These are both negative. Now if I'm talking about this end, so x is approaching, I'm now on the right-hand side of my graph, and x, we're talking about x is positive on the right-hand side. F of x is approaching, I'm pointing down below, and on the f of x scale, those numbers are negative, so negative infinity. So let's try some on your lesson practice. So page, I don't have the page for our lesson practice, but part A. Let me move that up and let me find the page for us really quickly. All right, we are on page 710 and part A. So part A, identify the leading coefficient and degree and describe the end behavior for f of x equals x to the 4th plus 6x minus 8. So our degree is 4, which in this case, right, 4 is an even number. Our leading coefficient is right there, which is an invisible positive 1. So I have a positive LC, but an even degree. So I'm looking at this graph here. My graph could look, it could do all kinds of things in the middle, but I know that the ends, that's what I'm focused on, is the ends. So I'm going to talk about the end behavior, and you could copy the end behavior from this table. I was just going over how to do it so that you could understand what this even is saying. But you could copy the table. Right here is x. This is f of x. So my end behavior on the left, x is approaching, x is approaching negative infinity because it's negative over here on x, where f of x is approaching, numbers up here are positive, so positive infinity. For the right, x is approaching, well, I'm on the right-hand side, numbers are positive on the right-hand side. And for f of x, I'm pointing up again, and up here, y is positive. So there is end behavior, and there is degree and leading coefficient. Part B, my polynomial is it f of x? G of x equals negative 2x to the 5th plus 3x to the 4th minus x. All right, so my degree is 5, which is odd. My LC is a negative 2, so I have a negative leading coefficient. So negative leading coefficient, odd degree, so I'm in this category here. My graph, I know, would look, I don't know what it does in the middle. We don't know the middle, but I know my ends, the top is pointing up and the right is pointing down. So again, I could just copy, this is the end behavior. Here is the left, here is the right-hand side. But I like to explain it as we go. So here's x, right? This is g of x. So on the left, x is negative, right? X is negative on the left. So x is approaching negative infinity. But my arrow is up top, and on top, g of x is positive. So g of x, whatever letter they gave you, is approaching positive infinity. On the right, I'm on the right-hand side. So when I talk about x, I'm talking about left, right. And when I talk about g of x, I'm talking about top, like up and down, because that's the way that our axes run. So I'm looking at the right-hand side, and I know that x is positive on the right. G of x, however, we're talking about down here. G of x is negative down here, so negative infinity. But again, that should match what it says on here. All right, moving on to C. They have drawn us a picture, and the picture in our lesson practice looks like, it's not a perfect scale, okay, guys? And it's asked us, does it have an odd or even? So looking at our pictures, it's not an even. Even, the arrows are pointing in the same direction. So they're either both up or both down. I have one pointing up, one pointing up and one pointing down. So based on that, I know that this is odd. And this one matches the graph down here, right, where the left is up and the right is down. So I know my leading coefficient is negative. And that is all it asked for on that one. D is the same as far as the type of question. I'm just going to draw a miniature, and they called this g of x. And don't worry, I'll move. And so I've got x and g of x. So again, I'm focused on, I don't know why they made it like the last one, I'm focused on the ends. And the ends are not pointing in the same direction, so I know it's an odd degree. And I know that it actually has the same as the last one, and so the left is up and the right is down, so I know that the leading coefficient is negative. So moving on to E. And they want us to graph the following function. So f of x equal, oh sorry, they said g of x, my bad. I'm always switching those out, and I apologize. So g of x equals x cubed minus 2x squared minus 5x plus 6. And I'm going to use Desmos, and I'm going to do it by hand. So here we go. I know that my possible zeros are factors of the last numbers. So 1, 2, 3, and 6. And I could find my zeros by using synthetics. I want to go over how to do it by hand and using Desmos. So remember, I'm looking for a remainder of 0. Now I have a degree of 3, so I can have 3 possible solutions. So bring down the 1, 1, negative 1, negative 1, negative 6, negative 6 is 0. So one of my solutions is positive 1. This is x squared minus x minus 6 equals 0. So I can factor that to be x minus 3 and x plus 2. So I should have a 0 at 3 and negative 2. So on graph paper, and I apologize, I didn't tear any out, but I have some right here. Let's draw what we have so far. I'm going to get Desmos out so I can, but I should have a solution at negative 2, 0, sorry, at 1 and at 3. This is at 3, 1, negative 2. And I know that my solutions, or my zeros, are also the x-intercepts of graph. And then I'm going to use Desmos for any maximum, minimum points. Okay, sorry, I keep re-zooming out, re-zooming in, moving. So let's use Desmos again. So in this case, I have x to the third minus 2x squared minus 5x plus 6. And so here is my graph. I want you to be able to see it. Hold on. My computer is locked out. So here's my graph, and it confirms if you touch on these dots, I have a x-intercept at -2, at 1, and at 0. Now this peak up here is called a maximum, and I have a maximum, it looks like at -0.78. Let's see here. Here's 4, and here's 8. So I'm going to plot that point. It's less than 1, but above. I'm going to put it here. And then I have my minimum at 2.1 and -4.1. So 2.1 and -4.1. And then I can connect my graph. And if you need to, you can use a ruler. And I'm going to make it look like that on Desmos. So there is my graph. Beautiful, beautiful, beautiful. Now, we call the tops our peaks. This is a maximum. And according to Desmos, that was at 8.209. I'm going to round to 8.21. And I would call any points that are like valleys or the bottom, right? This would be a minimum. And according to Desmos, y equals -4.06. Okay, and we only list the y values for that. So that is E. And I will tape that down. All right, next one. And this, all right, so let's go to F. Whoops, I should move that down to fit the graph. So F, I have g of x equals x to the fourth minus 4x to the third plus 3x plus 8. And it told us to find our local minimums and a local maximum. Now the word local just really means that there could be more than one. So in order to find that, I'm simply going to enter it and click on our points. So if you're not watching the video, it's mistaken. You should be watching these. So let me edit this. This is to the fourth minus 4x cubed plus 3x plus 8. And so here's my graph, and let me see if I can. There we go. And so let me show you that I have two minimums. I have a minimum up here, a bottom, and I have a bottom way down here. And so I'm going to identify both. So I'm just going to click on them. And if you click on the gray dot, so my local minimums, I have y equals 7.054. And if I go down here, I have negative 10.13. Okay, local maximum, right, would be the peak, and I have a peak to a mountain right here at y equals 9.076. And we are going to skip G, so that is it.